Today's global telecommunications industry now exceeds $700 billion annually. With double-digit growth to continue for the next decade, the volume of data will expand 17 times over in the coming 4 years. This burgeoning demand for bandwidth is driving industry to invent new ways to squeeze ever greater performance from the existing communications infrastructure. One company has the technology that will speed communication over existing fiber optics by more than a factor of 10. The company is cybercom. The technology is the photonic transistor, a device that will change telecommunications forever. This is cybercom's chief scientist, John Haidt, a pioneer in the field of all optical communication.
I invented the photonic transistor, which is the world's fastest transistor. Because instead of using electricity to turn other electricity on and off, it uses light to turn light beams on and off. As a result, we have the precision control of light, and far more information can be put through a single light beam than can be put through a single electronic wire. The photonic transistor is uniquely suited for operating telecommunications equipment at extremely high speeds. Over the years, the information in the telecommunications industry has been switching from copper wire to optical fiber because light will simply carry a whole lot more information. But in the industry, all of the interconnections between one fiber optic and another are electronic. And electrons in silicon go very slow in comparison to photons in holographic photonic transistors. So as a result, we will be able to multiplex far more information onto light beams than the optoelectronics industry will be able to accomplish with their methods. A single light beam is capable of carrying enough telephone calls simultaneously that every man, woman, and child on this planet could be talking to each other over that single light beam.
In the fiber optic equipment industry, what we find is that most companies are merely tweaking the same set of technological tools to try to achieve devices that are a little bit faster, cheaper, smaller, better. The improvements they're achieving are incremental, evolutionary in nature, not revolutionary. What I mean by revolution as opposed to evolutionary is that your typical product might employ a new type of architecture, but they're tweaking the same set of technological tools. So bottom line, what we see are evolutionary improvements of 10, 20, 30%. And these are very economically viable products. Don't get me wrong, they're very valuable. What we're involved in is in exponential, revolutionary improvements, because we've found a way to directly control light with light in such a manner that we can switch light at the speed of light.
The optical fibers that are now being installed can easily handle 100 times more information than the electronic equipment they're using is capable of supplying. Photonic transistors have the physical ability to eventually saturate those fibers to carry absolutely the greatest amount of information that the laws of physics will permit.
You know, I'm amazed. I have people all the time tell me that, isn't it great we have the information highway? And if you've ever downloaded a GIF file on the internet, I got to tell you, I don't know what kind of highway you drive on, but I feel like I'm driving on a dirt road with a bunch of potholes. Okay. So we're just crawling onto the information highway, and we believe with our technology we'll be able to maximize the capacity of fiber optic networks to deliver the needed bandwidth.
The photonic transistor uses light to control light at the speed of light. Its advantage is you can use very high bandwidth laser beams to control very high bandwidth laser beams. Inside the holographic photonic transistor, optical interference is used to perform this function at the speed of light. As a result, it is able to amplify and perform the Boolean logic functions needed to produce digital equipment. We expect that early in the 21st century, the vast majority of what is currently done with slow electronics will be accomplished with high-speed photonics. Why? Because it's smaller, it's faster, it's cheaper, it lasts longer, it's not subject to radiation, and because people want bandwidth. One thing we always want to remember, having too much bandwidth is like saying you have too much cash flow.
If you have a fast electronic switch, it switches perhaps every nanosecond, every billionth of a second, and the light travels maybe 200 meters in that period of time. Cybercom's photonic transistors can switch in a femtosecond, a millionth of a billionth of a second, the time it takes light to go about this far. Cybercom is on the brink of achieving what everybody calls the holy grail of telecommunications, the all-optical network. That means that we get to eliminate the incredible delays and expense of optical to electronic conversions that have to occur, for instance, in the repeaters and in the switches, all the way along the line. Cybercom is switching light with light, which is clearly the key to achieving the top speeds. A few of Cybercom's competitors, we suspect, may have figured this out for themselves and are attempting to duplicate what Cybercom has already done. Cybercom already has the holographic photonic transistor, but really, Cybercom's defense against these would-be competitors is not technological, it's in their patents.
These are pioneering patents. These are not merely improvement patents over what someone else has done.
Cybercom holds the rights to 10 patents directed at interference-based logic, specifically for the purpose of telecommunications use. Now, those patents include all wave-type energy, and so if somebody attempts to do telecommunications utilizing interference between the waves of tuning forks or interference between the waves of any other wave-type energy, including planar waveguides, including the ripples on a pond, they're going to have to deal with Cybercom and Cybercom's partners, and they're going to have to do business with us. Cybercom had an independent patent firm do an analysis of the 10 patents that were issued that relate to this technology. And let me just quote from the opinion of that firm. They said, the examiners inexorably admitted that no prior art teachings or disclosures taught, suggested, nor contained the basic elements as claimed. Now what that means is that the patent claims are so broad, and there was so little prior art, in fact in many of the cases there was no prior art, that it makes it impossible for anybody to copy or even come close.
So the advantages we have is A, we've done it, B, we've protected it, and C, we believe we'll be first to implement this type of technology. The strategic plan of Cybercom is to establish a toehold in the fiber optics industry by introducing our OTDM system as quickly as possible. This will validate the technology itself, and will also allow for the rapid introduction of our optical routers, which we believe will then provide the platform for very dramatic leadership in the telecommunication industry.
From the optical bench, which gives us an opportunity to lay out the large components of our filter system, we reduce it down to the 7th generation size on the optical bench. Finally, it will eventually be reduced into a commercial device similar to the one as you see here.
Cybercom is raising $70 million to pay for the commercialization, the manufacturing, the marketing, and the distribution of their first generation of optical photonic products. The investors that Cybercom is looking at fall into several categories. There are private individuals, there are equity funds, and most importantly, there are strategic investors, large existing players in the communication market that will work with us in the marketing and distribution of Cybercom's products.
Not only will this technology allow an industry partner to establish a leadership position in 21st century optical networking equipment manufacturing, but it will also, in my opinion, establish a position that can be unassailed by virtue of one fact. Unless Einstein was wrong, the speed of light is the ultimate speed limit in this universe. And while someone might be able to tie us, they'll never beat us because we're switching at the speed of light.
The preceding is not an offering for the sale of securities, which offer can only be made by prospectus. For a prospectus and more information, contact Investor Relations at Cybercom Corporation. Cybercom, switching light with light at the speed of light.